Here we're going to talk about the principal's choices as we move towards finding the Nash equilibrium. The principal is going to be thinking about how to maximize their profit. In so doing, we're going to be thinking about the price that they will offer given the quality that they expect, given the agent's best response function when we find the Nash equilibrium. To do that, though, we have to think about the following problem. How do we visualize and think through what the principal's choice is? And to do that, we're going to find their ISO cost curves, as you'll see in a few slides. So, in terms of the principal's cost minimization and the Nash equilibrium, we're going to think about the following. The principal has to make two decisions when they maximize their profit. They have to decide how many units to purchase, and that's basically equivalent to deciding on how many subcontractors to contract with. And they have to decide how much to pay for each unit. That is the profit maximizing price for them to pay. Okay, so what is that going to imply? Well, we're going to focus on how much to pay, because we're going to be looking at the question of how many people to hire in Chapter 11 as a separate question. For the moment, we're just going to think about this question of how much is enough when you're maximizing your profits. Okay, so what's the thing here? Well, the principal always wants to pay the least amount possible for the highest quality possible when they maximize their profits. That's the intuition that we have here. We want lowest price, highest Q. So, with that intuition in mind, we're going to study this price setting process. Because remember, the principal is in charge of how much they pay, so they're setting the price in order to get some quality back from the agent. We're going to proceed in 3 steps. Patricia knows Armand's, the agent's, best response, and knows that his best response determines the price PN that will minimize the cost of acquiring quality. Okay, so think about it this way, right? With Patricia, she's thinking, what is the lowest price I can pay given the quality he will provide? The price to her is a cost she incurs in order to get quality. Therefore, she has to decide to maximize her profit what the cost minimizing price is to get the quality she expects. Okay, so think about that for a moment or two. So 2 more steps. Step 2, Armand is going to best respond to the price that he has offered, as we'll see the Nash equilibrium price, hence PN, by choosing the Nash equilibrium quality, QN, which is the quality that maximizes his value given the price that he's offered by the principal. And then where PN and QN are offered, then the expected number of periods for the contract is going to be TN, the expected lifetime of the contract in Nash equilibrium, which is equal to 1 over T as a function of QN. T as a function of the Nash equilibrium level of quality. Okay, so those are 3 steps that we're going to be thinking about. And so we're going to focus here on this first step. Patricia thinking through what she's going to do with determining the minimizing cost for her. Okay, so here's the thing. If we have the same axes that we had previously, with price on the horizontal axis and quality on the vertical axis, what we have here are ISO cost curves for the principal. So what's an ISO cost curve? You might remember that an ISO cost curve is a curve for which costs are constant. So on each of these 3 curves depicted in the figure, along C3, along C2, and along C1, the costs along each of those curves are constant. Now, why does that make sense to us? It makes sense because the slope of those curves equal Q over P. It's quality per unit price. Okay, so they're just basically array from the origin, right? Array from the origin is going to have a slope which is Q over P. Okay, a given Q over P. So they're going to have that ratio, and we're going to see that the steeper the line, the more preferred it is by the principal. So you can see here we have the arrow saying better for the principal, saying that the steeper lines are better for the principal than the flatter lines. But in order to think that through, I want you to answer the following question. Why does Patricia prefer C1 to C2 and C2 to C3? To understand that, compare points A, B, and C. Right? So what do we see here? We've got these isocost curves with ratios of price to quality, where the slope is Q over P. And then when we think about that, we're going to say here that, okay, we've got Q over P, and we are trying to compare points A, B, and C. So for yourself, think about that for a moment. Why does Patricia, the principal, prefer C1 to C2 and C2 to C3? Look at points A, B, and C and see if you can answer that question. Okay, having taken a moment to try to answer that question, if you haven't yet, quickly pause and try and answer it. If we look at points A and B, the price there is 10. The price for all 3 points A, B, and C is 10. But at that price, comparing A and B, what do we see? At B, she gets a higher quality than she does at A. She gets a quality of 1/4 rather than a lower quality, probably around 1/8. And then if we compare points B and C again, what do we see? Well, point C versus point B, what do we have there? She definitely prefers point C to point B because at C she gets a quality of 1/2, whereas at B she gets a quality of 1/4. So understanding that, what can we see is happening? Given the price that she pays of 10, she wants to minimize her costs, which corresponds to getting a higher quality for the same price. So what does that imply? It implies that she always prefers a steeper isocost curve. So thinking about that for a second, what do we see there? She prefers the steeper curves to the flatter curves. Okay, so in thinking about that, the isocost curves, or the isocost rays, represent the cost minimizing objectives for the principal in her relationship with the agent. So we're going to have a whole set of isocost rays for the principal as she thinks through what she is doing in terms of her choice with the agent. Now, the slope of the isocost curve is the negative of the marginal rate of substitution for her. The marginal rate of substitution for her, right, is this trade-off that she's making between the quality that she receives for the given price, all right, from that slope Q over P. Okay, so thinking about that, we're going to be able to... So thinking about that, what are we going to be able to do? We are now going to proceed to the next step, and the next step is going to be incorporating these isocost curves, C1, C2, and C3, into what we had previously with the agent's best response function. And what are we going to see there? The principal is going to take the agent's best response function as the constraint on her maximization process, or as the constraint on her when she tries to minimize her costs. So, from her costs, we've got her MRS, her marginal rate of substitution. From the agent's best response, what does that mean we're going to have? It's the constraint on what she does, so it's going to give us the MRT. What's she going to do? She's going to pick the point where MRS equals MRT.